9:40. Thank you everyone for joining us this morning. My name's Benny Skelton. I'm the president of Cyclone Energy Group. I know quite a few of you I don't know, but I appreciate you joining us here today. We're going to spend a few minutes this morning, about 30 minutes or so, showing some presentation material on HVAC systems in multifamily high-rise buildings and airborne infectious diseases. We want to make sure everybody has good information on this. So as I mentioned in our agenda, we're going to start off by going through airborne infectious disease, particularly the SARS-CoV-2 virus that causes COVID-19. We'll talk about building operations and how you operate your building if you are an operator of a multifamily high-rise building. We'll kind of go through some of the things you can do there. We'll also talk about what you can do within your own home. And then we're going to talk about air cleaning and filtration, and we'll close up with some discussion on maintenance and commissioning practices. So with all this going on, there's a tremendous amount of new information every day. I mentioned this the first presentation we had last week on this, but I started putting the memo we sent to our multifamily high-rise clients a couple of weeks ago together back in mid-March, and the amount of new information about the COVID-19 coming in on a daily basis constantly kept the memo changing and getting more information to the point where I finally realized we just need to send it out and we'll just update it as we go along. So as we look for trusted information, we hear conflicting things in the media. We hear conflicting things from manufacturers and vendors and advertisements you might see. And you hear lots of things that can make you really confused about all of this. So one thing I'll preface, almost all of this entire presentation is based in the standards, guidelines, position documents, and recommendations of ASHRAE. For those of you not familiar, ASHRAE is a 57,000 international member professional society that has, I believe, chapters in over 132 countries. So they are a member-driven, consensus-driven organization that establishes guidelines for best practices. In particular, they have indoor air quality guideline. They have standard guideline 12 for minimizing the risk of Legionella in building water systems. They're working on other water quality guidelines and standards right now. As far as standards go, they are the organization that we follow here in the United States as it comes to indoor air quality and environmental quality. Most notably, ASHRAE standard 62.1 for commercial and 62.2 for residential for ventilation for indoor air quality. Standard 55 is in thermal environment guidelines. So a lot of the recommendations that are going to come out of this discussion today are going to be based on the best practices here. So like I said, things change so quickly. Even since I made this presentation, they've released a new position document on infectious aerosols. So originally I had based a lot of this on the airborne infectious disease position document and their filtration air cleaning position documents, which tend to get updated when epidemics or pandemics come out like this. But they've released a new, as of yesterday, aerosol guide. So I'll actually touch on that here in just a minute. The statement that their task force released yesterday is something that we have not heard much in the media for confirming about how the disease can spread through airborne exposure. A lot of what we hear about is surface transmission, but aerosol-based airborne transmission is of great concern, especially when we talk about building operations, because we're moving air in buildings. And a lot of this presentation, a lot of the memo we sent out came out of a lot of our clients asking us if they should be shutting down their buildings' ventilation systems, their makeup air systems, and that caused great concern. And so this position document says basically, changes to the building operations, including that of the heating and ventilating systems, can reduce the airborne exposures, and not having proper ventilation, filtration, and air movement can actually increase the risk of transmission and can cause direct life-threatening risks of the infection. So I wanted to just share that brand new statement from ASHRAE with you. All of you are probably sick and tired of hearing about this thing, but just so you have a clear understanding, this applies to multiple airborne viruses, but since this is the topic of mind right now, the virus that's being spread quite sneakily throughout the world right now is named SARS-CoV-2, and it transmits through multiple paths into a host, a susceptible host, which is pretty much anybody. And it forms the disease known as COVID-19, which is SARS is the severe acute respiratory syndrome. So it affects those particularly with lung conditions. But it is spread through multiple paths I'll discuss. So you don't kill a virus, you have to make it inactive. And with this particular virus, the way that it's spread is it has a fatty lipid layer membrane that surrounds the infectious portion of it. And if you're able to destroy that membrane, you're able to deactivate or inactivate the virus itself. One of the ways that you hear about in the recommendations from the CDC is washing your hands with soap and water. Soap dissolves fatty membranes. Soap does that when you're cleaning a pan with grease from fat on it as well. So it's the same basic principle. We're trying to break that fat down, and the 20 seconds of soap on your hand gets rid of that lipid membrane, exposes the virus, and it eventually falls out. Now that doesn't make it doesn't mean there might still be some toxins associated with it, but it loses its ability to infect you and result in the COVID-19 disease. There are multiple transmission paths for airborne infectious diseases. Like I mentioned, direct contact. This would be something like touching or kissing. If you have skin lesions, things that can cause you to become infected through direct contact. Indirect contact is touching something where the virus might have gotten put, such as a door handle. There's been research done to say that this particular disease can live up to 3 days or survive up to 3 days before it breaks down on stainless steel surfaces. So it has a fairly long life. But we're not going to cover direct or indirect contact today. That's not by any means my area of expertise. I'm an engineer, not a doctor, and you can certainly refer to WHO and CDC and other resources for information on how to avoid being infected through those paths. But we're going to talk about particularly airborne routes today, person-to-person contact through aerosols that contain these microorganisms. An aerosol is simply a liquid or solid that gets suspended in the air like gas. Think of a fog or a perfume or something that you can see lingering in the air. That's an aerosol. They can remain in the air for a particularly long period of time. Some of the research done on aerosolized SARS-CoV-2 virus has shown that it can stay in the air for at least 3 hours. So if it were in an aerosol environment, you could be walking into a fog that you can't see that could contain the virus. These aerosols exist all around us, and we don't always see them until we feel the effects of them. So airborne infectious disease through aerosol exposure, it typically happens through droplets. Now droplets can come from you by sneezing, by coughing, by yawning, by talking, and they fall in droplets that vary in size down to very microscopic particles. Like I mentioned, most of them in the larger range of droplet size that might sneeze will fall very rapidly from the air due to the forces of gravity and fall to the ground, where they again can remain active. And there have been studies with this virus; it can stick to the bottom of your shoes and be transmitted later. So these things are sneaky and bad. But the rule for and by the way, I drew this, not my daughter, but she would have done a much better job at it than I did. This graphic, done by borrowed from the ASHRAE position document on the aerosols, shows research done back in the early 2000s to show that coughing, that sneezing, these droplets, they fall out of the air, and as they fall out of the air, parts of it can evaporate and turn the virus into a very microscopic droplet that becomes this aerosol. I thought this graphic here on the left with the particle settling in the air was pretty interesting, that at 100 microns, your particle is going to stay in the air for about 5 to 6 seconds. But you can have a microscopic droplet under 0.5 that can remain in the air for up to 41 hours. So we'll talk about that as it relates to air movement filtration here. So in our buildings, we have heating, ventilation, and air conditioning systems that are constantly conditioning the air. In the state of a multifamily building, we'll have some centralized equipment typically to provide pressurization to the building, but generally most residents have their own HVAC system. And these systems, there's quite a few strategies we can take throughout buildings using these systems to help reduce our risk of exposure. One is dilution of air. So that's basically diluting the returned air that's going back into your unit from your space with fresh air. Airflow patterns, how the air is distributed through the space. Pressurization of the building and of your unit. Temperature and humidity distribution and control is definitely a topic of discussion. Filtration and ultraviolet germicidal irradiation, or UVGI. We're going to just briefly touch on each one of these topics here today. But at the end of the day, the best prevention and the best strategy is actually a combination of all of these. Not one thing alone is effective. We need a combination of multiple things for this to be a good strategy and protect you and reduce your risk of exposure. In this graphic of a high-rise building, or low-rise to high-rise building, this is a typical building, particularly we'll talk about the city of Chicago here. We have corridor makeup air, corridor pressurization units that distribute air down a building and typically pressurize the corridors. There are exhausts within the units, the residential units, for the toilets, dryers, and kitchens that run either periodically or all the time. And air is brought into the unit from the hallways through typically undercuts under the door, or there'd be some kind of transfer over the door, around the door, to allow the air in. In some instances, air is provided directly into the residential unit, not necessarily into the hallway, but typically this is the orientation that you're going to see in a high-rise multifamily building. So when I mentioned earlier, we were getting comments about people shutting off their makeup air and corridor pressurization units. That's actually a poor thing. That makeup air unit is there to keep you from having unit-to-unit air transfer, so air coming from your neighbor's unit into your unit. So when you shut that down, you could increase the possibility. If you've ever been in the building when you're having maintenance done on the makeup air unit and it is off and your exhausts are still running and you start smelling kitchen odors from someone else's unit, that's an example that you're getting cross-contamination from other units. So these units protect you. One thing that you don't want to do is start making drastic changes to your building's pressure control without some engineering behind it. You need to understand the testing and balancing that goes associated with these systems. These systems are here to provide you makeup air and pressurization, but they're also here to manage the stack effect of the building. The stack effect of the building is based on several factors: external temperature, internal temperature, wind speed, pressures. There's a lot of factors that come into it, but ultimately what this stack effect is doing to your building in the winter, when it's very, very cold, you might go into your lobby and you'll hear howling at the outside door, or the elevator doors might have a difficulty shutting, or that you hear wind noise when it's particularly extremely cold outside. That's because warm air is more buoyant than cold air, and in the winter, the warm air that we're introducing into the building rises through the building, and it looks for a path of least resistance to get out of the building, and typically that's your elevator and stairwell shafts. And so what happens is it makes the bottom of the building extremely negative. The top of the building becomes extremely positive. And if you've been in a building like this in a very, very cold day, and especially a tall building, it can be very frightening to open a door or a window at the top of the building, because the amount of air movement through it can be extreme. So the makeup air unit is used to try to manage the stack effect, to keep the pressurization through the building as comfortable as possible. It can't ever eliminate stack effect. It's always going to exist. In the summer, it's the opposite of what I just described. At the warm air is more buoyant. We're introducing cold air into the building, so the cold air that you're introducing actually falls through the elevator shafts, and it falls through the stairwells to the lower levels. Our lobbies can become overly pressurized at the top of the building. You'll be sucking a lot of air in when you open your window. One thing that we've seen a lot in multifamily high-rise buildings are people trying to get away with smoking in their units, and they're opening their windows either at the bottom or the top of the building, and that can actually cause unit-to-unit transfer, unit-to-unit contamination transfer, because the forces of stack effect can actually be stronger than the forces of the exhaust systems or even the corridor makeup air systems. They have more pressure drop associated with it, and so it'll break your stack. We've had one particular building where people's dryer fans were blowing into other people's units because people at the top of the building were opening their window and basically cutting the exhaust stack at that point. So you want to manage your stack effect carefully. You don't want to make drastic changes to your common area makeup air systems. These already provide 100% outside air to your building. There are some cases where there are recirculating hallway units. You'll need to look into that. If there are, in that case, you would want to increase your ventilation air to have more dilution. But in general, you're already bringing in fresh air, so it's more about filtration on these units. As we get into air filtration, air filtration is a lot more complicated than it looks on the surface level. A lot of times we just think, well, whatever particle goes through a filter, as long as the mesh and the fibrous membranes on the filters are smaller than the particle trying to go through, is going to catch that. And in general, that is correct. But there are other paths that allow filters to collect particles that are even smaller than the mesh that they have. This table here describes different types of filters that we have in our buildings. You can see this MERV rating is basically the efficiency of a filter, and I've categorized these into 5 different groupings by the type of filter that they typically end up being. Most of the time in our residences, we have fairly what I call inexpensive or typical cheap residential filters, which are little cartridge filters that are generally around MERV 7 or MERV 8. And so you can see the different particle sizes in the different ranges ASHRAE has defined here. 0.3 to 1 is range 1. They call that E1. Range 2 is 1 to 3. And then 3 to 10 is range 3. And going back to the droplets and the aerosols and the things that stick in the air, I'd mentioned microscopic droplets below 0.5 could remain in the air, according to that study, up to, I believe it was 41 hours. And so you're going to want a filter that can collect something in that 0.3 to 0.1 range if you're hoping to collect droplets of that size. Now, that doesn't mean we should all be rushing out and trying to find HEPA filters to put on our furnace. In fact, high efficiency and ultra efficiency filters aren't really designed for residential units. What they can do is they have so much pressure drop because they're basically so thick that and so resistive that your furnaces will often lock out because they'll have gas, and you can't. It won't have enough airflow to allow the gas to ignite, and your unit will shut down. So we always recommend higher filtration. If you can get to a higher quality residential filter, a MERV 11 and a MERV 12 filter tend to be what manufacturers like Honeywell and 3M tend to advertise as their allergen control filters. Those are very good in commercial grade filters. Then in the bag and the box size, we recommend no less than a MERV 13 filter. Many of our clients are able to do MERV 14, MERV 16 filters. So higher filtration is one great strategy. So as I mentioned, filters can catch something that are smaller than what their physical size is. If you look at this column for range 1, because we're going to look at the 0.3 micron range here, a MERV 13 filter can capture 50%, up to 50% efficient at capturing particles below the 0.3 micron range. So it's collecting things that are smaller than it should be able to collect just by the physical size of it. So that's a good thing for everybody to see that they're very efficient. When we get into the HEPA filters, now we're talking about 99.97. This is what we use in hospital surgical suites. Hospitals don't even use HEPA filters for their general areas. A lot of times they're using a MERV 14 or MERV 16 filter for general areas. It's really just the high contamination zones, like the surgical suites, clean rooms, that get these HEPA filters. So filtration, as I mentioned, is one technology that we can improve. We can bring more air in, more fresh air into our building. We can filter it better to clean it out, try to capture particles. Another technology is ultraviolet germicidal irradiation. Most of us have heard of the abbreviation UV, but it is actually spread into 4 different spectrums. As we look at the full light spectrum, we have infrared at the very high heat area of light, where this is often used in thermal imaging of buildings. We use the infrared light source. We have the spectrum that we see in day. When we look outside, we can see from 400 to 780. That's our standard rainbow. Ultraviolet falls in the 100 to 400 range, and then the X-ray falls below that. So there are multiple ranges of UV. UVA is the most common that we see on Earth. 95% of all UV that we have on the livable surface of the Earth is UVA. It's very harmful radiation. That's why, as is UVB. UVB gets through the atmosphere in smaller concentrations, but can be particularly harmful to your skin. This is where sunburns and things like that can come from. That UVB can't penetrate further than your skin level. UVC does not exist in our livable Earth surface area. It gets absorbed entirely in the atmosphere, but it is the range of UV that is optimal for UV disinfection. 253.7, let's round it up to 254, is the optimal wavelength for UVC for disinfection. Given the type of lamp that we can use, which is typically a mercury vapor light bulb. That's pretty typical that can be installed. So anything below 200 in the ultraviolet to vacuum range is potentially dangerous because it produces ozone, and ozone is one of those things that is not our friend. We don't want to introduce ozone into our environments. We've had quite a few people in the commercial realm asking about installing ozone generators in their space at night when they leave. As does ASHRAE and as does the Centers for Disease Control and Prevention, all recommend not using ozone generation devices. There is no published safe limit for ozone. It's been said maybe 10 parts per million by volume is acceptable, but there's no good science behind any ozone saying that it has anything but negative health benefits. There is limited research that does show it has the ability to minimize airborne infectious diseases, but again, that's mostly based in manufacturer research. So we don't recommend anything that produces ozone whatsoever, because it is known as a dangerous factor. So ultraviolet, UVC, UVGI, it basically sends photons into the cells and the DNA, I should, of these microorganisms, and it deactivates them. So it's a very effective strategy if it's done correctly. It is not as simple as installing UVGI and saying I'm taking care of the problem. It actually needs to be very, very carefully engineered. UV is very dangerous for exposure. So because it deactivates it or kills the bacteria, it doesn't remove it. It still exists, and the particles of it, as I mentioned before, can often contain still harmful mycotoxins. It just eliminates the ability to be infected with the disease. UVGI, by and large, is used in healthcare environments, and it's used in the upper zones typically. It's not used at surface levels. If you go into a hospital, hopefully you're not having to do that now, but next time you can safely do that, you'll often see these spread throughout. This has to be extremely carefully engineered because exposure to UV is very, very dangerous. So they usually put it in the upper zones, combined with proper air movement. The amount of airflow across a UV system, as well as temperature and humidity, all do affect the ability of UV to be effective. So there are several different types of UV for applications. There's air disinfectants, which are most commonly we see put in air handling units. They put in between the filter and the cooling coil. It's very good at the filters to catch up airborne infectious disease or microbial particle that needs disinfection. The filtration can catch it. The UVGI can deactivate it or kill it. The UV is used commonly on cooling coils to take care of cleaning the water. It's also used to somewhat of a lesser extent in the condensate drain pans that collect the condensate off the cooling coils, also to eliminate bacteria. So it can also be used in a standalone surface application. So there are robotic, kind of like Roomba UV generators that hospitals often put in patient rooms to disinfect after they've been, the patient has been removed from the room. Some people use them in like on a tripod, and they can put them in temporary, but they are intended for temporary. They typically come with special glasses you need to wear when operating them. So be very, very careful with the application of UVGI. Make sure it's used in a compatible spot. The NIOSH, I took this from an ASHRAE presentation, but the exposure limits for the 253.7 optimal wavelengths of UVC for disinfection in ductwork applications is less than 10 seconds, and protective gear is required. So if you're working on a piece of HVAC system with an in-duct system, such as an air handler, or if it's put into an airstream, you're going to want to basically not be exposed without any kind of protective materials. The upper air zone, I've got a typo here, it should say 8 hours, not 1 hour, at the 0.2 size exposure, that's a power input exposure. This is out of the working and breathing zone. This is in the upper zones. Is up to 8 hours, and that's intended because most people aren't going to be in the space, in a single space for that long. So safe exposure of 8 hours is good for these upper air systems. Temperature and humidification are also important. As these droplets, say you were to sneeze or cough and droplets were to come out and start to fall, they evaporate, and droplet nuclei come out of that. And these are the particles that can turn into these dangerous aerosols that can remain airborne for considerable amounts of time. So humidification and temperature are things that can help reduce some of that. So some research is suggesting that lower relative humidity can help rapidly change these particles because it increases the evaporation. So meaning if we have really low humidity and these particles come out, they can turn into an aerosol much faster at a lower humidity level. So most people are recommending a much higher relative humidity level. As it applies to SARS-CoV-2, the virus in particular, the research is suggesting, again, nothing conclusive, but temperatures in the range of 86 degrees Fahrenheit and relative humidities of 65% are the area where the virus is dropping out of the air much faster. Clearly, that's not a temperature and humidity range that we would want to live in. We may want to sit at a beach with that, but we don't want to have that in our house. In particular, especially in the winter months, too high of humidity can be a big issue with condensation. So we do want to keep some minimum level of humidification within our spaces because we want to avoid getting dry, cracked skin, which can make us more susceptible to infection. ASHRAE doesn't specify a lower humidity range, but through ASHRAE standard 55, but it does recommend no more than 60% relative humidity in the summer at a 75-degree indoor temperature. Our cooling devices tend to keep us around 50 to 60%, Anything higher can actually cause, again, condensation in places you don't want it, which can promote mold growth. In the winter, using a 70-degree temperature range, you're going to want to try to maintain between 30 to 40% relative humidity if you have that ability to do that. But you're going to want to be careful with that. Older buildings, particularly those with older windows, a higher relative humidity can cause rainfalls on your windows. It's particularly in colder weather when you have higher humidity levels, like 30 to 40%. Some buildings don't have the ability to humidify to this level. Sometimes the makeup air units and the hallways have humidification in a lot of buildings. Again, we see most buildings trying to maintain about a 30 to 35% relative humidity in the hallways, which does actually go into the units. Some units and some buildings have their own in-unit residential humidifiers. These have to be very carefully watched because they tend to be pretty cheap. They tend to fail pretty often, pretty frequently. So you got to make sure you monitor it and watch it. You want to shut it off in the summer and make sure it doesn't accidentally turn on. I know particularly I've had a furnace where there was an in-unit humidifier and it would drip water onto the furnace and it rotted the furnace out over time. So you want to be careful with how you operate these in-unit things. And again, you don't want too high a humidity level. You don't want to promote mold or condensation. So a couple other filtration technologies, and we'll close here. The ionizers are electronic filters that work using coronas to ionize air. There's conflicting evidence that these are effective at removing airborne particles. Again, most of the research done on these has been done by manufacturers and hasn't been done by independent research organizations. And the studies that have been done on the effectiveness of health by these filter systems have shown ranges from absolutely no benefit to some benefit. So there's really not a lot of science here that promotes the use of these yet as an effective tool. Ozone generators, again, there's significantly conflicting data on effectiveness, and as far as the health effect goes, some people have reported that it's had a great effect on health, but most of the time we know that any exposure to ozone can be dangerous to our health. So we want to say we don't recommend using ozone generation, even if it's in an unoccupied space, even if it's at night, particularly if you're not monitoring the levels of ozone through sensors. I mentioned dilution. This is the bringing in of ventilation and fresh air. A lot of times in your residences, you don't have the ability to do this because the window is the dilution source. Open your windows if you can. If you can open your windows whenever you can, do it. Again, in systems that have recirculation, you're going to want to try to increase ventilation if you can to promote fresher air. This does come at a cost of energy as a penalty. Typically, when you're heating or cooling air, more ventilation air costs you to heat and cool more air. So there is a balance there, but in general, this is one strategy that you can employ. And one last topic that strays away from the COVID-19 for a moment, but is Legionella. Legionella forms in cooling towers. It forms in cool, warm, dark areas. It becomes aerosolized as water comes out of cooling tower fans and systems, and can be, we know from being in Illinois, from our nursing home issues, that it can be very devastating to health. Not only cooling towers, but your indoor plumbing systems and fountains. It's really highly suggested if you're in a multifamily high-rise building and you manage it, that you have a Legionella and water quality plan. This typically comes into buildings where you have residents that have unused bathrooms, where showers or faucets may go unused for months at a time because someone might be a snowbird and go to Florida for the winter. We recommend that buildings have a management plan where people go through and management goes through when units are unoccupied and exercise showers and faucets. Typically, any kind of Legionella that would become aerosolized out of a shower head or a faucet would happen within the first 20 seconds. After that, it typically clears. But these colonies, they form in unused and still water in dark areas for long periods of time. So a frequent testing for Legionella in your building is recommended. There are guidelines for this, putting a plan together is not overly complicated, and it can be very helpful. And finally, maintenance and commissioning of systems, just a few recommendations. Change your filters regularly or per the manufacturer's loading recommendations. If you're monitoring central equipment, a lot of times you're monitoring pressure drop. You want to make sure that the filters are maintained properly, that they're not letting air by that should be getting filtered. You want to maintain fans and belts. You want to make sure everything's tested and balanced properly in your building so that air is being distributed the way it's been designed to. If you have a building with dampers on ventilation systems, recirculating air handling systems, those dampers can often fail and be unseen. So you want to test those on a regular basis to make sure that you are bringing proper ventilation in when you think you are. As I mentioned, test for Legionella and any open water source, such as cooling towers or fountains. You want to make sure that you always chemically treat that. So these are just a few recommendations and tips. And so with that, I'd like to conclude and open this up for questions. If you have questions, feel free to jump in or put it on the chat. If not, we will be publishing this PowerPoint later if you want to go back and reference it. So I think that question was asked earlier. Well, if there are no questions, I definitely appreciate everyone's time this morning. I hope you found this valuable. If we can be of any assistance to you and your building, please don't hesitate to reach out. Stay safe, follow the CDC guidelines. And again, if you have any questions, if you'd like any of the materials I've referenced today from ASHRAE, we'll publish the list with links to you on that. We do have one question. How often do we need to change filters in air handling during this particular time? Increasing filter changes isn't really going to do anything unless you're doing some kind of disinfectant to the filter. So if you have a UVGI source on it, you don't need to change your filters very frequently on your unit because it is deactivating any viral thing. But increased filter changes can help remove if you don't have a disinfectant source. So such as like your furnace in your room. Question, are there concerns of carryover in droplets and energy recovery wheels? That's a great question. Their droplets can carry over in a desiccant like that. So yeah, there definitely is concern in that case. Typically, that would happen after a filtration source. So having a UVGI type disinfectant would deactivate that in that case. There's another question. Your recommendation for filters on rooftop units is minimum MERV 13. That a minimum MERV 13 is our minimum recommendation. That's correct. A lot of times units will have like a MERV 8 or a MERV 11 as a standard filter. Replacing those with a MERV 13 can cost a little bit more. In the range of MERV 13 to MERV 16, if you have the ability, we recommend a MERV 14 and MERV 16 filter. And if you want to keep it in a place where you're not spending a tremendous amount of energy because you have a higher pressure drop filter, they make a V-bank filter, which is a lower pressure drop filter that has a higher MERV rating. That costs a lot more, but they are extremely effective. They don't load up as fast. They last, in recirculating air handlers, we've seen them last up to 18 months without even having pre-filters on them. So a MERV 13 to 16 filter in a V-bank configuration would be our recommendation for most rooftop and air handling, central air handling units. Any other questions? Great. If you have any other questions, do please follow up. Feel free to call us. More than happy to talk to you one-on-one about it. Questions or concerns about your building, let us know. Again, appreciate your time this morning. Hope you all stay safe and well. Thank you.